Welcome back, viewers. So, in today's section, we are going to discuss the polymers of CBSE class 12. So, there are two similar words that are commonly used. One is polymers, and another one is macromolecules. They appear to be same, but they are totally different. Polymers are called as macromolecules due to their size. Remember, but it is always not true. But macromolecules may or may not contain monomers, but a polymer contain monomers. What are monomers? In the upcoming segment, we are going to discuss in detail about what are monomers and what are polymers. And remember, here you see chlorophyll, best example. Formula of chlorophyll is almost a big molecule. It is C55, H72, O5, N4, and as you know, the metal present is magnesium. This is the best example for macromolecules, but this is not a polymer. Then which substance we have to call them as a polymer? Remember, polymers are those molecules which definitely have monomers. Means a large number of monomer. Monomer means very simple units or simple molecules. These simple molecules are joined and so as to get the big molecules, they are called as a polymers. But in macromolecule, these simple units are not at all present. So that is what the major difference between the polymers and macromolecules. Therefore, remember students, when these monomers are joined, how many monomers? N number of monomers. This N number is not a simple 100 or 200. It is almost 1000 lakhs together. When these N monomers are converted into polymers. And this process of conversion of monomer into polymer is also called as, polymerization. Remember, what is this process is called? Polymerization. That is converting or joining a large number of or n number of monomers into a big molecule called as a polymer. This process, a simple process, can also be called as polymerization process. So I think you are very clear with the two words. One is polymers and macromolecules. Both are bigger only, but macromolecule may or may not contain monomers, but polymer definitely contain monomers. And when you convert this monomer into polymer, that process we simply call it as what? Polymerization. Since we already know the basic content, I think now it is very important for us to go in depth. You can classify on the basis of source of origin, means how they are extracted. Okay, they are classified on the basis of source of origin. This is one of the classification. And second one, based on structure they are classified. Remember, based on structure they are classified. And third one, they are based on mode of polymerization and how do you prepare them. On that segment also they are classified. And fourth one we have based on molecular forces. What type of molecular forces are existing between two different or three different monomers? That another type of classification. At the last, I think these are the major four classification which are coming under the polymers to make their study very easier one. So one by one we are going to discuss down. So here what will happen, I think easily you can visualize. Source of origin. Here polymers are broadly classified into three segments. One, you can call them as a natural polymer. These are quite easy, students, easily you can understand. Second one is a synthetic polymer. and the third one is semi-synthetic polymer. What are those? Natural polymers, synthetic polymer, semi-synthetic polymer. See, natural polymer, obviously these occur in the nature, or they occur in the plants or animals. These all are called as natural polymer, students. Example for this are commonly, that is, you already know this, proteins, cellulose, starch are the major example, or some other examples which are occurring in the plants and animals. These are also the example for natural polymers. And coming back to the synthetic, these are man-made polymers, students, remember, not naturally occurring. These are man-made, we can synthesize them in the laboratory. Best example for this is the polyethylene bag, which is commonly called as polythene, and polyvinyl chloride, PVC, polyacrylonitrile, PAN, polymethyl methyl acrylate, PMMA. These all are some example for synthetic polymer. And coming back to the semi-synthetic, and these polymers, they are obtained by making some modification in the natural polymer. Or in a simple way, they can be almost said like they are the intermixing of your natural and synthetic. These are also prepared artificially only. Best example for this is cellulose acetate and cellulose xanthate, or you can, best example is vulcanized rubber. Later onwards in the same lesson, we are going to study in detail about this vulcanized rubbers. So on the basis of source of origin, they are broadly classified as synthetic, natural, synthetic and semi-synthetic. One which occur in the nature are called as natural polymers. One which can be synthesized by the man artificially, they are called as synthetic polymer. And some modification in the natural polymer by artificial method, that we call it as semi-synthetic polymer. And common examples I have listed over below. One among them will serve the purpose. Now coming back to another type of classification, which is quite important, that we are heading towards that part of content. This is based on structure. Here also almost we have three classification. One we call it as linear polymer. As the name suggests, they will be straight chain. Some are called as branched chain polymers, and some are called as a cross-linked polymer. I think if I draw diagrammatically, you can easily visualize. If I draw these structures, see, these are called as linear polymers. In the same linear chain, if there are some branches like this, these are called as branched chain polymers. If two linear chains are connected one another, then they are called as a cross-linked polymer. So remember, linear polymers, example you can go with nylon. I think these common word you might have heard. Polyester, we commonly call it as polyester. These are the some example for linear polymers. And branched polymers, we have almost like starch and glycogen. These are some example, or low density polyethylene, we call it as LDP. These are the some example for branched chain polymers. And cross-linked, here we go for bakelite and glyptal. These are the common examples over the cross-linked polymer. So I think cross-linked means they will be having some rigidity in them because they have extensive cross-linking. So these polymers, that cross-linked polymers, they are rigid, brittle, they are very hard because of extensive cross-linking or connecting two different monomeric chain. So these are some of the examples or the types of polymers based on their structure. Three major over here also: linear, branched and cross-linked. Then coming back to mode of polymerization, means how you prepare them. How you prepare them, that we call it as mode of polymerization. How you prepare? So on this one, they are classified into two different segments. One we call it as addition polymers, and the second one is condensation polymers. These are quite important, students. You need to highlight over these two. If a same monomer is added 100 or 1000 times, the resulting polymer is called as addition polymer, and the process is called as addition polymerization. Best example, I think you can go for polyethylene. Here, the ethene is added 100 times, 1000 times required quantity, so that to get a polymer, that type of polymer can also be called as what? Addition polymerization. Here, nothing is eliminated. Single monomeric unit is 1000 times added, or lakhs together times added. But in condensation, students, these polymers are formed by combination of monomers with the elimination of small molecules like water in majority case, alcohol in some cases, or HCl in majority case. If these are eliminated, then the resulting polymer can also be called as condensation. I repeat again, in addition polymerization, nothing is eliminated. Just a monomer is converted into polymer. But here, 2 or 3 monomeric units are joined. When you join them, there will be the elimination of H2O, alcohol, or in HCl. Majority case, H2O eliminates. In such case, they are called as condensation polymers. So this is all about a very simple classification, that is mode of polymerization. Then coming on to the fourth one and the last classification, students, that is classification based on molecular forces. Here we can go with almost 4 different types of classification. We have elastomers, next we have fibers, and we have thermoplastics, and the fourth one right here, thermosetting polymers. As the name suggests, what are elastomers? These are almost like rubber. They have elastic property, right? They are held together by weakest intermolecular forces. That's why they can be stretched into any extent. And once the force is released, I think they retract to their original shape. Example is rubber itself. Then coming back to the fibers, these class of polymers which are almost thread-like, see this word, which are almost thread-like and can be woven into fabrics. These are widely used in making cloths, nets, ropes, gauges, etc. And the fibers, they possess a high tensile strength because of their chain possess a strong intermolecular force as compared to your elastomers. And coming back to thermoplastics, here these are linear polymers, students. Remember, these are linear polymers and held together by weak, I think you might have heard about this word, van der Waals force of attraction. Weak van der Waals force of attraction. And these forces are intermediate of those of your elastomers and fibers. They are not even weakest like elastomers and not strongest like your fibers. Best example for thermoplastic is your polyethylene. Very common example of it. And coming back to thermosetting polymers, these are semi-fluid molecules. Remember, these are semi-fluid which have low molecular mass, but when heated, see, that is what the word is, thermosetting. I think you might have heard about setting of cement, how it becomes hard mass once you add water. Here also, if you heat them, thermo means heat. If you heat them, they become hard and infusible mass due to extensive cross-linking. Remember, if you heat them, they undergo extensive cross-linking and become infusible mass, and they become very hard. Best example for this is bakelite. So these all are 4 types of classification based on molecular forces. I think first one is elastomers, fibers, thermoplastic, thermosetting polymers. I hope with respect to classification, I think there is no difficulty over here. So in next part of the video, we are going to discuss about types of polymerization of different monomers. Thank you for watching.